Hey everyone, welcome back to Bitwise Smarter. If you're new here, this is part 3 of our Python for Beginners series. In part 1, we covered the absolute foundations, variables, data types, input and output, basically how Python thinks. In part 2, we learned how Python makes decisions using conditions, comparisons, and logic, how your code chooses what to do. And today, we take the next big step. We are teaching Python how to repeat, how to organize, and how to automate real life tasks using loops, functions, and clean logic. By the end of this video, you won't just understand loops and functions, you'll build a real world automation project you can reuse again and again. So, whether you're continuing from parts 1 and 2 or starting fresh today, let's write some Python that actually does work. Section 1, Randomness in Python. Computers are predictable by nature, but real life isn't. If you want Python to pick a random song, choose a random habit, select a random reminder, you need randomness. Python gives us that through the random module. Let's run this code. Import random gives us access to Python's randomness tools. Snacks is a list, a collection of values. Random.choice of snacks picks one item at random from the list, and the print statement shows it nicely using an if string. Let's look at the first mini challenge. Create a list of break activities like stretch, drink water, walk 2 minutes, look away from the screen, then randomly print one activity. Pause now and try it. Here is a probable solution. Let's run it. This is the same pattern: list, random.choice, print. Once this clicks, randomness becomes easy. Section 2, Lists. What a list really is. Think of a list as a shopping list. Instead of making 10 variables like milk equal to, bread equal to, eggs equal to, you store everything inside one container. Let's look at an example. Errands equal to groceries, laundry, car wash, post office are all stored in one list called errands. Python counts positions starting at 0. Errands of 0 means the first item. Negative indexing is a shortcut. Errands of -1 means the last item. Errands of -2 means the second last item. This is a clean way to grab the start and the end of a list. Let's run this. Next up is modifying a list. Lists are editable. Errands of 1 equal to dry cleaning means replace the item at index 1. Dot append means add a new item to the end. Lists are living containers. They change as your program runs. Let's try this. Let's look at another challenge. Create your own edits list with at least 3 items. Replace one item. Append one new item. Pause the video here and try this. Here is a probable solution. Let's run this. You're modifying the lists in place. This is critical for real programs. Data rarely stays the same. Section 3, For loops. A for loop is Python saying, take each item in this list one by one and do something with it. This is how we avoid copy-paste code. Here is an example. Let's run it. Python takes the first name and stores it in name. Then it runs every indented line. Then it goes back up, grabs the next name, and repeats. The loop runs once per item in the list. In Python, indentation is not optional. It's how Python understands structure. Let's look at this example and run it. When Python sees this line, for name in friends, the colon means a block of code is coming. Every line indented under it belongs to the loop and will repeat once for each name. So print hi, comma name runs three times, once for Asha, Ravi, and Meena. The line print all greetings done is not indented, so it's outside the loop. That's why it runs only once after the loop finishes. If indentation changes, program behavior changes, not just formatting. Here is another challenge. Loop through this list and print task completed followed by the task. Pause here and try the challenge. Here is a probable solution. Let's run it. This runs once per task. This is clean automation. Section 4. Loops plus numbers. Python has built-in functions like max, but rebuilding them manually is one of the best ways to understand loops plus conditionals. Because you start thinking like a program. How do I scan values and keep the best one? Let's look at one example. Here's the strategy. Start with a guess. Max score equal to scores of 0. We assume the first value is the maximum for now. Compare every value. The loop goes through each score s. Update if we find a bigger one. If s greater than max score, we replace max score. So max score is like the current champion. Every time a bigger score shows up, the champion gets replaced. At the end, the biggest one survives. Let's run this. Max score equal to 99, which is the maximum score in the list. Time for another challenge. Add up all the study minutes using a loop. Pause here and try it. Here is a probable solution. Let's run it. This is the accumulator pattern. Start at 0. Add each value into total. Total grows each time. This pattern is everywhere in real projects. Totals, counts, sums, tracking progress, etc. Section 5. Range loops without lists. Sometimes you don't want to loop through a list. You want to loop through numbers 1 to 5 or 1 to 10 or 0 to 100. That's what range is for. Range generates numbers for you. Here is an example. Let's run it. Range 1, 6 creates 1, 2, 3, 4, 5. It stops before 6. So range start, end means start at start, stop before end. Then the loop uses each number automatically. Time for some practice. Print numbers from 1 to 10 using range. Here is a probable solution. Let's run it. To include 10, we stop at 11 because range stops before the end. Section 6. Functions, reusable commands. Functions bundle instructions under one name. Think of a function as a custom button. Instead of writing the same steps again and again, you write them once, give them a name, and call them whenever you want. Here is an example. Let's run it. Here we have two parts. Part 1. Defining the function. Def daily motivation. This creates the function. Like writing the recipe. Everything indented under it belongs to the function. Part 2. Calling the function. Daily motivation. This runs the recipe. Important note. If you only define and never call, nothing prints. Time for some more practice. Create a function called morning checklist that prints three lines. Make coffee, open laptop, write today's top task. Then call the function twice to simulate doing your routine 2 mornings in a row. Let's pause and try it out. Here is a probable solution. Let's run it. Let's break down exactly what's happening. Defining the function. Def morning checklist. Def means define. Morning checklist is the name of our custom command. The parentheses are there because functions use parentheses even when there are no inputs. The colon means everything indented belongs to that function. The indented block is the function body. These three print lines are the steps inside the function. So Python is basically saving a recipe. Step 1, make coffee. Step 2, open laptop. Step 3, write today's top task. Defining a function does not run it. It only stores it. Calling the function, morning checklist. Now Python actually executes the saved steps in order. And since we call it twice, Python runs the same three steps twice. So instead of copy pasting those print statements again, we just reuse the function. Cleaner, faster, and easier to read. Section 7, While loops. A while loop runs as long as the condition is true. A for loop is great when you know the number of repeats. A while loop is great when you don't know and you just want to keep going until something changes. But it's powerful and dangerous because if the condition never changes, your loop never stops. Here is an example. Let's run it. Cup starts at 0. Condition 0 less than 5 is true. Loop runs. Print happens. Cups become 1. Then Python checks again. 1 less than 5. True. Runs again. This repeats until cups become 5. Then 5 less than 5. False. Loop ends. And cup plus equal to 1 is the escape hatch. Without it, cup stays 0 forever. And here is the final project, building a habit tracker. This project combines everything you learned today. We are going to store habits in a list, randomly pick today's plan, print it neatly, ask what you completed, count progress, and give summary and feedback at the end. This is a type of a script you can actually reuse in real life. Let's pause and try it. Here is a probable solution. Step 1. Import plus habit menu. First, import random because we want daily variety. Then we create habits, a list. Think of this list as a menu. You're not doing everything, you're choosing a few. Step 2. Pick today's plan safely. This function has a job. Pick count habits from the habit menu. Inputs, habit list, the menu, count, how many habits today. Now the safety check. If someone asks for 20 habits, but we only have 7, we prevent errors by shrinking count. Then random.sample habit list comma count picks unique habits, no duplicates. Step 3. Print the plan with numbering. Plan is a list of selected habits. We loop through using enumerate. Enumerate gives us the number I, the habit text, and start equal to 1 makes it human-friendly numbering. Step 4. Checklist plus progress counter. This function is the interactive part. Done equal to 0 means we haven't completed anything yet. Then for each habit, ask the user, convert to lowercase so y and y behave the same. If yes, increment done. If no, gentle message. Finally, return done sends the count back to the main program. Step 5. Random reminder. We store reminder lines in a list. Then we pick one with random.choice reminders. So every run starts with a different vibe. Step 6. Main program flow. Now the program begins. We print a welcome message, then call random reminder to show one motivational line. Step 7. Safe user input using try except. This is real world safety. We want an integer, but users might type 3. If Python tries int of 3, it crashes. So try means attempt conversion. Except value error means if it fails, don't crash. Use a default. Defaulting to 3 keeps the program usable. Step 8. Build plan, show it, run checklist. This is where the functions work like Lego blocks. Pick today's plan, returns a list. Stored in today. Print plan of today, shows it nicely. Run checklist today, asks questions and returns a number. Stored in completed. Step 9. Summary plus feedback logic. Final reporting. Length of today tells us how many habits were assigned today. Then we give feedback. If completed equals today, you did everything. Else, if you did at least one, solid effort. Else, still positive because showing up matters. This is clean logic and it makes the program feel like a real app. Let's run it. And that's Python for Beginners Part 3 on Bitwise Smarter. And now you know how to store values in lists, repeat work with for loops and range, build reusable code with functions, and use while loop safely without getting stuck. If this video helped you, please like, subscribe, share, and I'll see you in the next one.